welcome to Finals Week, Day 4. So today is all around AI and AI enablement. And by AI enablement, we mean that all of the projects that are going to be presented today, we believe have got a direct impact onto our products, our community, and a route to the upstream. So i.e. not just doing AI for AI's sake, but really doing AI that will enable us moving forwards. It's great to see so many people on the call today, and it's great to see members of our AI for working group joining in as well for this special edition. So a really good audience for our presenters. Our first up today will be going to Vickey for his project. It's really good to see some of these projects to just cover little bits around the edge and really will increase what we're able to do, especially in terms of inclusivity and things like that. So Vickey, are you able to come off mute and are you able to share your screen to go with the
Yes, sir.
presentation? Excellent. Thank you
Hello.
for that, Vickey.
So, welcome all everyone. It's my project is voice-driven banking by LAN. That is the large acoustic model. So, the main problem of this project is to use the bank by the all individual communities that have a illiteratures and that have the language barriers and all of things. So in mostly language in mostly countries and the uh, others, mainly issue is the to how to organize in a bank in a their relative or their regionless language, just like in mostly they are English, and but other country having different kind of languages. India, just like India has a many kind of language, Marathi, Gujarati, Hindi, and just like Spanish and German. So I'm going to develop a voice-driven banking by large acoustic model. That my model having a large capacity of a language. Then uh, here here you can uh, take your all kind of question by using your voice, just like in a simple, you can say what is my balance of my account. Then my lamb model will transfer that the interaction between the user and the bank is by the using the voice. This is the main process of my project. So this is, and the mentor was the Akshat Kumar and the Part Kaushal and Lalit sir also. The motivation is that I am already tell that many rural community lack digital banking access, and overall 1.3 billion adult lack basic digital literacy skill and this kind of thing. So I make on a platform that is very useful and easy to use by using the voice. And the main idea of the voice is by using the LLM. So our LAM model is similar to Gemini. That Gemini is using text to text interaction, but now it's also available to voice interaction. So this is similar to the LLM, but having the voice to voice interaction between the user and the client. And so this for this I have used different kind of a models like TTS, STTs. That is the TTS is means to text to speech conversion. STT model is used speech to text models, and this kind of a model. And also I implement the factor, the voice authentication, and two-factor authentication by the using the OTPs. I will say you by the ending the demo, but the flow chart is that anyone start start listening by the using my website, my web page, and yeah, using the voice command. Then command is converted to speech to text conversion. After that, the LLM having by using the API, that's I generally using the Gemini API, and then your voice is authenticate. And after that, if your voice is good, I mean in means authenticate valid, then go proceed by biometric pins, and also verification is good, and then go with the banking actions and this kind of result. And then Gemini result. After that Gemini result, that is in text form, but the user should be here the jam system model. So text is converted to voice. After that, I am using the TTS model that it and after that the system speak back, and this process is going on again and again. And that is the tech stack I am using. So my main motive is the main motive of this project is using the uh, lamb model to train this. So we have initially lack amount of data. So I generally use the Gemini and open source LLM models. That is very useful. So I am using the fast API by interaction between the backend and the front end. I am using the Hugging Face models just like Whisper and Michelle, and the TTS model is the Facebook's something, and React for the front end. For the demo perspective, I using the Firebase database, and this is a system architecture that I am using. That I already told that voice to input convert the text to speech ratio, and then LLM interaction between and Selenium that will automate in the futures, and the speech to text, and finally authentication. So this is, and I have a demo for you. Uh, so
How
this
are
is the
you?
interaction between the
Like,
my system
and
and
this is
the
trying to
interaction.
go to with
So
the
here I ask something similar question, what
backend part is
hello, what's
ready,
that something
and
related.
backend is services
After
heavy.
that, the
The
interaction will
starting with
confirm,
the HTTP,
and that in
the
on the
health,
basic of that, the
starting with
NLU
this,
part is
and
happening.
I'm here to help you with your banking needs. I can assist with things like checking your balance, reviewing transactions, or transferring funds to get started.
Here the system is saying that I can only help with your bank related questions, and that and some demo that you can ask me what is my account balance and the list my 5 transaction, that kind of things you can ask by my
You
AI
could ask
then.
me, where's my account balance, or
this
list
is
my last 5 transactions.
so this is the task. This is
And after that okay,
so this is a demo part. Let's start with the
so
English. So
I have different
right
kind of
now it's
questions.
fetching the data on the basic of the Firebase. So I am currently using this account. This is my
Just give me a minute.
right now it's fetching different question. Let
Okay, just give me a minute. I have little bit confusing the slide one. Okay,
so
here
this is
this
a
one.
demo part. Let
Hayes.
and same thing is happening here. That
Here I ask what is the balance of my account. Then the system is repeating saying that
so this is a demo. Okay? This is a simple question that I asked. On the basic of that, I have provided a different kind of services. This is only the demo part, so I am going with the demo and the lectures. This is the that time of
Your savings account ending in over shows a recent credit.
here I ask that what is the last transaction, and that is the debited or credited. So on the basic of that, that the transaction detail is here mentioned, that is the scripted and generated by using that is scrapped from the Firebase database, and here represent the transaction detail, and your saving account ending with this showing the recent credit of a 200 of something that you have recently transferred to 200 rupees. That is the my questions, and this is the some similar other things. And similar to this kind of a question you can ask by my models, and you can also
so this
transfer the
I
money
need
by
to put the
using
account number and my
Please
two-factor
check your
authentication.
email
account
for the
number. The OTP is correct or not? What is the balance here? Again, the what is the correct? So
balance or
this is
list
Okay,
my
this okay. After that, if you have to transfer some money to your friends, your colleague, then that my assumption is that you already fill their account number and that kind of things. So my assistant here asks you, okay, that is your confirm that. After that, OTP verification is sent to your registered email address. After that, email address verification by using the uh, voice, and that then you provide the OTPs. Then this is trans then the my model is transfer that amount to your respected receivers. And this kind of models I have generate and make it. And I have a different kind of
First one is
uh,
the
language support, that's like English, Hindi, Marathi, Gujarati. And I, for initial, I have used the 21 languages. That is good enough for the initial phase. And this is the one of the interaction. What is the happening behind the scene? That the server is starting up, and after that the assisted model is going on, and that the all the services initialize, and after that the service is converted. That this similar one. And uh, this is going on, and the transaction, that your voice is converted to text by using bank balance of my account. And that bank balance of account is by using the performing the NLU. Then NLU will be transfer intent to entities mapping. That intent is the check balance, entity is something. And after that processing the by using the local IDs, that the local user is the Vickey Kumar, and the section ID is something this. And the conversation, I also manage the conversation between the assistant and the that kind assistant and the user. And the content is the how can this is the previous stuff, previous response and turn. After that the check balance, and then account data is this. This is all going is behind the scene. And your current save, after that the generated response is that your current saving account balance is 1000 rupees. And after that that kind of a text is converted by using the Facebook MSS TTS model, that is converting the text to speech model. After that the model is generated, and the language is detected, that the language is English. And you here the model is also detect which kind of language you are saying. If you are saying Hindi, then the model is automatically detect and say that the response is also coming in the Hindi. Also, if you speak in German and you speak use Spanish, then this kind of already done by the models. And this is the backend happening. And this is the my future perspective, that the what we have to do in the future in this project. That initially I assume that the data set we do not have enough amount of data to train the model and train the LLM and the NLP. So in the future we have to generate data sheet. And and also we have to voice authentication, enable that by using a different kind of model. We have to search and allow by the with the voice authentication. Here I initial phase I have used the OTP verification for the authentications. And we can also increase the model expenses by using the continuous improving the model performance and scoping for the future enhancement. That is, thank you.
Thank you very much, Vickey. That's very exciting to see, and it's always good to see a demo actually working in practice. It's lovely to see that it's actually getting to be quite a mature capability with a mature interface, and we'll have to work out how we can get that in some deployments that we've got coming up. Next, staying on the theme of accessibility and language, we'll be going across to Shubham, who's been looking at accessibility and language improvements to increase accessibility, inclusion, and adoption. So, Shubham, if you'd like to come off mute and share your screen, that would be great.
Hi everyone. Yeah, so my project is accessibility and language improvements using AI. And the project is focused on making Mifos more inclusive by breaking the language barriers and ensuring that users worldwide can access the financial services in their own language. So here is a quick roadmap for how we will continue. First, we will be looking at the problem that we are trying to solve. Then we will look at the proposed solution. Then we will see the approach that is taken and the next steps. So let's start with the problem first. Mifos application basically has support for many languages, but there are three major issues that are there. First is that the translations often lack context. So for example, a word in English may have multiple meanings, but the translated version might pick up the wrong one. Second, there are inconsistent across different apps. The same feature may appear with different wordings in the web and mobile app. And third, it acts as a barrier for non-English users which limits the adoption and trust in global communities. So now financial services are already very intimidating for many users. And if the interface is unclear, it can actually prevent people from using it. So inclusiveness and accessibility are very core to this problem. So now looking at the solution. So our solution is to move beyond a basic dictionary or Google Translate style of conversions. And instead, we are proposing a context-aware translation model, which is powered by LLMs, which are large language models. So for that, we will start with raw translation files that are present in JSON format, and using LLM APIs, the script will generate translations that aren't just literal translation, but also natural sounding and context aware. The output will be a new target language file, which will be aligned with the meaning of the original file. And because we have also implemented human review into this process, we can improve the quality of translations. And this can make the final result far more friendly and accurate. So here is the approach. We first analyze the translations that are present in the Mifos UI, and we design the code to first parse the JSON language file, which is present in English language, and extract the various keys and values present there. Then we identify the text, which will be used as the context for making the translation to the different language. And this will be then provided to the LLM by creating a context-aware prompt. Then we use the Grok LLM API, which gives us access to Llama 70B model. And we have tested this with various other models like Gemini API also. And we used Llama 70B because of its proficiency in language translation. Then we have also used a caching mechanism, which basically helps us to avoid redundant calls and save the cost and time which is required for making an API call. So if there is some text which has already been translated, it will not be translated the next time if we are trying to run the same script again. Then these translated text are saved in the required format in a new JSON file. So the tech stack that we are using for this is Python, which is the primary language for the translation script, and Grok API key. And the format for our language files is .env. For securely managing the API keys and other environment variables. Then we are using libraries like TQDM for tracking the progress, since the files are very large and it takes a large amount of time to convert a single file. So here is a demo example of how the generated files look like. So the first image that you can see is from English to French, and then the second image is of English to Italian. And similarly, we have done this for 13 other languages which are present. And this was for the web app part. Now moving on to the mobile app problems. So on the mobile side, translations are a bit different since we have strings.xml files which are present in Android as opposed to JSON files present in the web app. So here the thing is, there are many different sections present in the mobile repo which have the same name as strings.xml and which are present in different folders present all across the mobile repository. So here also the problem is same, that there are inconsistent or incomplete translations which lack the context. And some languages have partial coverage, and some of the translations are done literal wise as opposed to the context aware. For mobile users who rely on apps in these critical financial situations, bad translations can create confusion and distrust on the app. So for solution for mobile app, so since now we are dealing with XML files instead of JSON file, we will have to change the strategy for parsing the files, since there are different tags and how we extract them from the XML files. Another thing that was considered in the mobile app is that there were multiple files present in different directories within the repositories. Unlike the web app, where all the translations were stored in a single JSON file, and all the translated files followed a similar pattern. However, this was not the case for mobile app. Mobile app had various folders which had the files which had the same file name for different languages. So we had to manually find each of the string.xml file in the particular folder, and then the tool automatically parses this file and compares them to the English-based version which is present and identifies the string which needs translations. In some cases, it was found that one file had more or less translations than the English file. So if it had more, they were kept as it is, and if it had less translations, then the translations which were present in the English file were converted and then stored in the new XML file. Now then we use the same strategy and we use the LLM to generate a context-aware translation and preserving the Android structure so that the application remains functional. So for the approach taken, we first find the string.xml file, which is present in different directories in the repo. Then we parse the language files and we extract string and string arrays, which are two types of entries present in the XML file, which needs to be translated. There was also an issue of that some text was not to be translated, and that was present as a tag translatable equal to false. These strings were skipped as these should not need to be translated. So example for this would be Mifos. So like the word Mifos need not to be translated into different languages. Then it identifies the text for translation, and then we create a context-aware prompt. Then the next step is similar to the one that we did in the web app, which basically we provide this context-aware prompt to the LLM API, which we are using as Grok, and we use Llama 70B and a newly released model GPT OSS 120B, which was found to be much better. And then again, we have also incorporated human feedback into the loop so that the accuracy can be verified. And also here also a caching mechanism is present, which can help us save redundant calls and save the cost and time to make API calls. Then we save this translated text in the required format in a new XML file. So here's the example of how the files look like after the translation has been done. And as you can see, this is an example which has been done for the Indonesian file. And this is how it looks like, and this is the workflow. So now the next step for this is that we are adding a functionality to not just add the translations, which keep on getting updated in the Mifos repos. So basically, currently the files that are generated have a cutoff date of 15 August and before. So basically, the files that were present in the repo before 15 August have been successfully translated. However, some things were added later on. And now we need to add a functionality which will only select those texts that need to be translated and convert them into a new file, and convert them into a new language. And we also need to develop a user-friendly interface for developers and release managers. Thank you, and this is from my side.
Thank you, Shubham. That's excellent. As I say, one of the problems we often get is how can we stretch out our products to be able to cope with different languages and enable, therefore, people that don't speak English or French, etc., to be able to access our products. It's great to see those improvements flowing through. Keshav, are you ready and able to present the first of our ones looking at AI applications?
Sure. Hello, everyone. So, my name is Keshav, and I was working on the MCP server for our payment hub application. So, let's get right into it. So, this is just a brief overview of what I was doing. So, it would contain the brief introduction to MCP, the current progress of the MCP interface, and as well the additional thing I was trying, which is basically fine tuning small language models for tool calling, well, which I had tried in using with the along with the MCP. So let's get started. So, like, what is MCP? MCP is like a USB-C drive, USB-C port for all the APIs. Like, how it works is that we have around like a bunch of APIs, like around 10 or 20. So if we want to use like all of them, we would need to write a function for, or do a call command for each of them. But this is how MCP comes into picture. Like, there has been a huge demand for using MCPs these days. Like, companies and all that, even startups are getting built on just the MCP server. So yeah, that has been quite a boom. So basically, it works like we are providing LLM like a sort of a superpower so that it can utilize the set of APIs endpoints that we have. So it's like that. For example, we would ask LLM to, hey, just get the weather report for today in India. So the LLM would see that, hey, this is the kind of request that I cannot solve it on my own. I need something like external tool. So in that case, we would be passing our MCPs to the LM so that it understand that, hey, this function I just need to call that. So I will develop the schema which is required to calling this endpoint. Like for example, this weather API. So I will just put the headers down and just call it right away. So to develop MCP servers, there are like multiple libraries. Like we can use it via fast API. We can use a fast MCP, and we have like some TypeScript integrations and all that. But for this scope of my project, I was working with fast MCP, and it was a bit easier to set up as compared to fast API, which I was starting off with the which I just started off earlier. And it also has like cool features where you can use decorators for the prompting, for the resources and all that stuff. So this is just an example how we would use the @rate tool as a decorator so that it can be exposed to our MCP. So, so yeah, the key features of our MCP server are like self-service registration, the authentication login, the account transaction access, beneficiary fund transfer, and all that stuff. You can check out the repository for that. Yeah. So this was just a page I was trying out, but I later on shifted to just using it with deep chat, or you can use it with cloud code. So I will be presenting a demo for that. Yeah. So we are starting off with how we would be using the repository to build it. So let me just speed it up. So this is the configuration file which we need to use. So this is here we are using a deep chat interface. Like it is a really cool interface which you can use to test out your MCPs. Like it has a really cool chat interface like ChatGPT. So yeah, I mean, you can try it out with the Claude desktop too. That's a really good option too. But here I, but here I my mentor Victor recommended me to use the deep chat because like it has a much better performance as compared to other aggregators. So here I just made a small error. I will just speed it up and show you. Uh, yeah, so now it would be working. I just had misspelled the path. So here the tool would be enabled, and you can notice that I'm using Quen 3 4 billion parameter model. So which is basically a small language model which I'm using, so that I can test it out. Like I tried like Quen 3 billion parameter. I tried Kimi, sorry, and Gemini, and all those large language models. But my purpose was to to see if I can extract some power from my Quen 3 4 billion parameter, which is running on my CPU. So yeah, you can see the progress for that. It is a bit slow because I'm not using the GPU integration as of now. Uh, yeah. So it is able to identify all those relevant tools, and we are also able to make the relevant calls. Let me just, I also have demo for that. So this is one simple query we are testing it out. Yeah, I'm already typing it out because I know I haven't passed the complete parameters. So yeah, it would ask us to prompt us to just implement all those required parameters which would be needed for the self-service registration. So that's So this is the done portion states that the API call has been successful, and it is going through the like all the reasoning part. Yeah. So this has been confirmed. Yeah. So I'm checking out if I have received the email. So that means the registration was successful. So we are just confirming out if it works. So yeah, this one works. So I'm just testing out like how it behaves with the response that I have received in the email. Yeah, so this error I was facing it because uh, it was already registered, and that's why I was getting that. But as you can see, the email which I had received, it just confirmed it. So yeah, this was the demo works fine. And for the rest of the presentation, we'll go ahead. Yeah. So yeah, this is basically the REST API endpoint that we have, and we have our base URL as well as student ID. And now I was experimentally fine tuning the small language models. I am still am like I started off with the synthetic dataset part so that I can test it out. But yeah, I was getting my model to hallucinate a lot. So I just tested out the Quen 4 billion parameter model one to without any fine tuning. And yeah, as you can see, the results were actually fine. I mean, I didn't really expect it would work that well. And even it was better than Llama 3 8 billion parameter model, which is like a really good model. But yeah, even small language models are good with tool callings. Like Quen 3 was already fine tuned well. So yeah, we didn't really need to do fine tuning for that part. But yeah, I was trying out the Gemma 2 billion model one, but uh, it hallucinated a lot for me when I was using the synthetic data set. But yeah, if you use a normal LLM API call, normal LLM APIs with the MCP server, the results would be just fine and perfect. So yeah, this is it from my side. Thank you.
Thank you very much, Keshav. It's great to see all the work you've done on MCP. It's a demonstration of how far AI has moved on in just a year for our interns. In that last year, MCP didn't even factor on the radar, and this year it's a really key part. So it's great that you've been able to work with Victor and take that forwards for our community. It's impressive stuff. We'll move to Norbline now. Norbline has worked on the AI-driven testing framework for security, so use of AI to help us improve and understand our security posture. So, Norbline, if you'd like to present.
Hello everyone, my name is Azah Noblin, and today I'll be presenting my project titled AI-Driven Architectural Testing for Mifos Payment Hub EE, mentored by Kelly Mani and Urelua. The Mifos Payment Hub EE is a large-scale financial transaction system used to process critical payment across multiple channels and services. Because it is handling money, it requires very high level of availability, security, and reliability. The challenge is that in such a complex system, even a small failure like one component crashing or a sudden spike in traffic can cause a chain reaction that impact the whole service. So traditional testing methods don't always capture these real world scenarios. That's where my project comes in. I have designed and implemented an AI powered framework that not only simulates stress, load, and security attacks on Payment Hub, but also detect anomalies in real time using machine learning. So in this presentation, I will walk you through the approach I used, the testing I perform, covering performance, scalability, resilience, and security, and how the AI model helps predict and detect issues before they escalate. So by the end of this presentation, you will see how this project strengthens Payment Hub EE by making it more resilient and secure, while also showing the potential of AI in system testing and monitoring. So let's write on to the approach I used. So in the approach, I started by deploying Payment Hub EE with all its services, then integrated Open Telemetry as a sidecar. This allowed me to capture logs, metric, and traces in real time without modifying the Payment Hub EE code base. So logs flow into Elasticsearch and metrics into Prometheus, giving me full visibility in Kibana and Grafana dashboard, as you can see from my screen. So I simulated real-world traffic to the channel transfer endpoint using JMeter. I ran three key scenarios: warm-up traffic, stress test, and spike test. This helped measure how Payment Hub EE behave under normal loads and sustain heavy loads and sudden traffic surges. The collected results combined with system metrics show where bottlenecks occur and whether response times or error rate increase under pressure. In parallel, I ran static and dependency security scan using CodeQA, NPL audit, and Trevi. This allowed me to uncover vulnerabilities in both code and third-party dependency. Instead of just listing them, I fed results into an AI model pipeline to prioritize what matters the most. So the heart of the project was integrating an AI anomaly detection model, isolation forest. I trained it on a historical logs and metrics collected through OpenTelemetry, fired in Elasticsearch. This helped the system automatically detect unusual patterns such as spike in latency or abnormal error distributions. So whenever anomalies were detected, the bot raised alert through Slack, making it proactive rather than reactive. Finally, I package the AI board as a Helm chart and as a customized add-on. This means anyone running Payment Hub AA can drop it into their cluster, get monitoring plus anomaly detection instantly, and even retain the model periodically using a cron job. So I will move right ahead to the finding. So when running the spike test, when I push sudden surges of traffic to the system, I observed latency spikes and some services querying requests. This gave me clear thresholds where the system struggles under real-world spike event like payday or festival rush. So during the stress testing, I had to go beyond the normal capacity. I forced the system into failure. The goal wasn't just to break it, but to understand how it breaks, whether gracefully with error messages or abruptly with crashes. This helped train the AI model to recognize stress conditions before they escalate. And for the scalability, I then tested horizontal scaling by adding more ports. Results showed that while scaling work, certain components like database became a bottleneck. This data is important for the AI model because it shows patterns of bottlenecks build up. And for resilience, by restarting critical components like ZB, Kafka, and Keycloak, I check how quickly the system could recover. Logs from this experience help the AI to detect early warning signals when recovery is slower than normal. On the security side, tools like Trevi and CodeQL reveal dependency vulnerabilities. These results are not just static reports. I input them into our AI-driven testing framework, enabling the system to predict when vulnerabilities could become active threat. Overall, each of these tests generated structural logs and telemetry that I fit into the isolation forest model. This allowed the AI to efficiently detect problems such as anomalies, bottlenecks, or potential breaches before they impact the users. So I'll move right on to the achievement. So through this project, I was able to achieve a number of milestones that directly strengthen payment hub EE. So at this point, instead of just telling you, I would like to show you a demo video of it. Hi everyone. In this demo, I'll be showing the AI-driven architectural testing board I built for the Mifos Payment Hub EE. The Payment Hub EE is a critical financial system, so it needs to be resilient, scalable, and secure. The board I have built continuously monitors logs and metrics in real time using Elasticsearch and OpenTelemetry. It detects issues like malicious transactions, overloads, and back pressure in CP, security failures in Keycloak, and it also detects if issues are tenant specific, and even anomalies detected by machine learning models like isolation forest. All alerts are automatically posted into Slack with runbook guidance so that operators can respond quickly. In this short demo, I will show you two examples. First, how the bot detects a malicious transaction payload, and second, how it detects system back pressure in CPU. So let's get started. So I started the bot already, so it's running already. Let's look at how the bot handles malicious or suspicious payload. So I will be using chain method for this. So I will be sending a normal request, like for example, extremely large transaction values like seen here in the amount field, and cross-site scripting as seen in the node field. So I'll just go ahead and to the test. So requests are being sent right now. So everything has been sent, so I'm going to stop it now. What actually happened is these requests are captured in the channel connector logs, and the bot uses its payloads anomaly detector to scan them. As soon as it detects unusual patterns such as invalid field or potential fraud indicators, it raises an alert in the Slack channel. Let's go ahead to it. So as you can see, an alert has been posted already. The message not only reports that a suspicious payload was found, but it also shows a sample of the actual request so that the operator can immediately understand what is wrong. As you see here. So if a payload looks like fraud or a system misuse attempt, the alert helps the operation team to act quickly so that they block or investigate on the activity. So yeah, this demonstrates how the AI-driven bot isn't just catching performance issues like back pressure, but also protecting against data integrity and security threats in real times. Okay, so we'll move straight ahead to the second scenario. So I'm going to be using JMeter again to simulate heavy load on the channel transfer endpoint. So we'll be simulating the scenario of ZB gateway back pressure. So I think I already have that set up already. So what I'm going to do right now is to set it back to normal. Yes. So everything is set up in the thread group already. Need to clear this. So due to the requests that have been sent in, it looks like the system is exhausted already and it can no longer take requests again. So okay, this is a good a good scenario. So here in my screen, you can see my Grafana dashboard showing CPU usage and system metrics. So as you see, as the load increases, you will notice CPU usage climbing and the gateway struggling to handle requests, as you can see from my screen here. And behind the scene, Elasticsearch is collecting logs and the AI bot is monitoring for signs of back pressure as it did already when I ran the request and the system was exhausted already, as you can see from the request from the alert that just came in, because the system is exhausted and this is Elasticsearch collecting all the logs and feeding the AI with it. So this was a perfect example. You can see specifically log message like writer is full or fail to write client request. So the Slack message not only highlight the error but also include a runbook with next step like checking broker health or expecting partition leaders. So this show how the bots can catch issues early and guide operators towards fixing them before they become system-wide outages. So today we have seen how our AI-driven testing framework monitors Mifos payment hub EE in real time, detect anomalies and highlight potential risks before they impact users. This approach not only strengthens the system reliability and security, but also provide actionable insights for continuous improvement. With this framework, we are turning complex system monitoring into a proactive, intelligent process. Thank you. So we'll move right on to the impact. So this project not only deliver a working AI-driven test framework, but it also impacted me personally. I grew stronger technically and learned how to push through setbacks, and I also learned how to communicate efficiently. Technically, the framework can now be reused by anyone running Payment Hub EE, and for the community, it provides a foundation for making financial system more reliable and scalable and secure. So, in conclusion, this project shows that AI-driven testing can make payment hub a more reliable and secure. I prove it possible to simulate failure, detect issues early, and automate responses. And the next step is to expand the AI model, package a framework so anyone can use it and apply it in bigger production scale environment. So thank you.
Thank you very much, Norbline. That's great work and a really good demo that brings it to life. A topic that's not easy to demonstrate. So thank you very much for doing that. And it's good to see other potential areas we could actually use AI to really address things such as security. We'll now move over to Aru. Aru's been working on AI chatbots, taking forward the work we did in a project last year. But again, as I say, the AI field moves on very substantially in the period of a year. So the tools and the abilities that are available are very different. So Aru, if you'd like to come off mute and share your screen and take us through what you worked on, that'd be absolutely great.
Oh, cool. Thanks, David, for the introduction. Hi, everyone. So, yeah, I worked on the generative AI chatbot for community support. So, the idea behind this project was to extend what we built in the last edition of Summer of Code. And after that, basically, when I started contributing to Mifos, I realized that the community go way back to around 10, 15 years where a lot of discussion was happening during the initial stage of the development. So at the very start, I was just focused on creating a tool that can just summarize what is happening in our Slack channel. And somebody who's a newcomer or who wants to start contributing to any of the project, they can get an idea. Okay, this is the status of all these channels. Because I like messaged a lot of people from Mifos in when I first landed over there, and I was able to get a reply only from David. So I thought the mentors are super busy. So what if there is somebody who just wants to know something about what is happening in the development and none of the mentor is able to answer? So this chatbot can look at all the messages that are there in our channel and then it can provide a reasonable response to that. So the first idea was to use a RAG. But when we were exploring that direction, we realized that we want something that can be used in a real-time interface because RAG is expensive when we have to recompute all the embeddings and delete the older ones. So we thought, how about using an agent? So starting with an agent, we just kind of extended the support to not just a single agent, but a multi-agent ecosystem. So this is the overall system design of our project. That is, the user just logs in using his Google Auth credential. That is being authenticated by Firebase. Then it goes to the main page. This main page has a couple of agents, like a main start agent, a Slack agent, a Jira agent, and a GitHub agent. So they can just put down their query, and these particular agents will be generating a response with respect to the query that we have got from the user. So what exactly are these agents? So we are giving an input. There is an LLM, which is OpenAI in our case. We just give an input, and on the basis of our input, it has a couple of tools, and it uses those tools to generate an output. Suppose the output is not accurate, then there is a feedback loop that conveys a message to the LLM that is there so that it can refine its responses. In our case, I have just explained the functions that are available in our Slack, the Slack bot. So it can get the details of our channel, it can send a message, it can read a message that is there. But apart from that, there are a couple of more endpoints as well, which I haven't covered in this one, but they are available in our bots that we are using. So I have attached the links to all those websites in this PPT. So later on, you can take a reference from here. So this is one of the capability that is there in our particular chatbot. So I gave it a hash. This hash is nothing but basically a channel ID of our various channels in our of the various channels in our Slack channel. So I just asked it to generate a summary and send it to the test channel. So it was able to do that. If we don't want to send the summary or if we just want to try something else, maybe it should respond to a particular call. Maybe it should trigger upon whenever a new user is added to give a summary of that. So that can also be done with this. All we have to do is to go to the Slack API token that we're creating, and we have to modify the permission. That is there in the PPT on on the second half. So then we have this GitHub agent. So GitHub agent is basically something that can just crawl all the data that is there in our GitHub repository. So when I was recording this demo, I created a test issue in one of my repository where this bot is deployed. So it gave me, okay, this is the latest issue that is there. So I asked it to, can you add some sort of a comment on that? It was able to do that. Lastly, we have this Jira agent. So the Jira agent is kind of, I would say, in a very initial phase because it uses a JQL. And when in my initial testing, I wasn't able to like get this bot working. Then after a couple of iterations, I built some pipelines that can convert our natural language into a JQL. So it can give a high level overview of uh, in our what is happening in our Jira tickets. So an extension of this project is something that we are planning to announce next in the next iteration that is there in the Hacktoberfest. So we'll get to it later on. But yeah, this is the initial stage of it. So a lot of people who were trying to set up this project, they were kind of confused about how to get the keys that are essential. So for the OpenAI key, you can get one from the OpenAI platform. So I won't be talking about it. So it can easily be available. But the other keys for the Slack, Jira, and GitHub agent that I have created some sort of a demo to get an idea. So for this one, we have to have a Slack account in a developer mode, and then we just have to go to a link that is there in this uh, presentation. So after going to that, you can create some sort of a bot with whatever name that you want. You can add some scope to it. With scope, I mean what all features do you want your agent to do? Do you want it to read? Do you want it to write? Do you want it to schedule a message, schedule a call? So all those features can be done in that. So after that, you have to request because earlier it was just anyone can come and install an agent into our workspace. But after our testing, we this particular thing was changed. So once you will get that agent installed into a particular workspace, then you will be getting a key. That key is your Slack agent token, and it can be set in the environment variable that we have defined in our README file. Next is our Jira agent. So for the Jira agent, you have to not get into the developer mode, but the link that is there in this uh, presentation, you have to go to that, and you can set an expiry date where when do you want this token to expire. Apart from that, there is also scope in this particular uh, Jira API, but the scopes are kind of complex, so I haven't covered in this. But if somebody wants to talk about that, they can definitely reach out to me, and we'll talk about it in detail. So lastly is the GitHub agent. So we have to go to the developer settings. Then in the developer settings, we can create in GitHub app. So this GitHub app could be named anything, but see if another app is not available from that name, that should be unique. So you just write a description. This homepage URL could be anything. That doesn't need to be a website. After that, there's a webhook URL that should be a web application that is available on the internet. So you can also set some sort of permissions for a repository, for an organization, or your account. This is how you can simply create an app. So for my case, demo app was already available. Demo app test was also available. So I added just a name to make it unique, a bunch of numbers. So once you have this bot ready, you can just install it in your repositories. If you want to install it on all the repositories your account, that is up to you. Otherwise, you can just handpick some particular repositories that you want your bot to be on. So yeah, this was the part where I covered about our the work that I've done in form of screenshot. I'll just give a brief demo from the bot that is there. I'll just reshare my screen again. So yeah, this is what our interface looks like. So suppose I have to know about what is happening in the FinRat channel. So I can just ask it, what is happening in the FinRat channel. So it will take some time, and it's going to give me the, I would say, what is happening in that channel, a brief summary of all the discussion that happened in a recent time. So sometimes what happens is the channels that I'm trying to communicate it to, the bot is not added to them. So at that time, there should be a scope that we should add the bot to that particular channel. Then only it can read and write from that. And sometimes it doesn't go by the name as well. So we have to give the channel ID as well. So this is what it gives. So if somebody can go to our channel on our Slack, they can verify this from there. So Jira Assistant, suppose I want to know what are the projects associated to Mifos. So this is like a very basic question that we can get an answer when we use this particular agent. So what it will do is it will go to our Atlassian API and it will sort of uh, make a call to that, and it listed all the projects that are there in our particular repository. Now for the GitHub Assistant, suppose I went there and I created a new issue. Okay, demo issue for the demo description. This is not an issue, and I created it. And now I'm asking it what is the latest issue in the. So right now I've just installed this bot in my particular repository. You can also do the same for any other repository that you want this bot to be on. So I asked it, okay, what is the latest issue in that? And this the sec and gives a message. So yeah, now the point is if I ask it, he can you add a comment to it? So it also has a write permission as well. Can you add a comment? It's not an issue, but a feature. So it will be able to do that in our repository. It's not an issue, but a feature. Now, if I wanted to create a new issue, so can you create a new issue titled as no issue? So it will simply deny because it doesn't have the permission to do that. So it will give a message that I think you do not have the required permission to create an issue, and it just gave the resolution, okay, I cannot do that, and you should go and create an issue yourself. It makes a couple of tool calls before that, so it's taking a bit longer than the other responses that we have. Oh, let me see. Was it able to create an issue? No. So this is a hallucination that the model did. I mean, I encountered it for the first time, but yeah. So this is one of those reasons why I haven't deployed the bot yet, because right now the bot doesn't really have any sort of a security guardrails. So I was reading about them, and in the by the end of this month, I was preparing a V2 for that. And in that V2, I'll have some guardrails so that nobody can jailbreak or get into our Slack channel and uh, put a bunch of crap that we don't want people to like add to our channels. And apart from that, there are also permissions issues that is associated with our particular project. And this is something that I have to discuss with my mentors. So what all permissions do we want our bot to be on? What is the level of availability for the users? So yeah, this is our bot. If you want to try it out, if you want to play around it, have some feedback, and if you encounter some issues, so please go to our repository that is there on the Mifos AI working group. And if you have some doubts, you can just drop a message on our working group for AI channel, or DM me via Slack. Or if you want to, if you encounter an issue, you can just go to our repository and create an issue over there. We also have a Jira board that we usually that we kind of use to have our used to track the progress of our project. So yeah, that's it from my side. Thank you so much.
Thank you very much, Sharu. It's very impressive. I like the live demo at the end, always a brave thing to do. But yeah, certainly that's moved forwards a huge amount from where we are last year. That concludes our presentations for today. I'd like to thank all the interns that have presented. It's great to see the work that you're doing. I think you can all be very rightly proud of what you've achieved. That also concludes finals week for us as well. So finals week is kind of come to an end, but it's also just the start. So we refer to it as our endless summer of code, because this is just the start of these interns working within our community, really taking things forward. And we've been delighted to see past year's interns move on to maintainer roles and even mentors for the future years. So we're very pleased to hopefully get some of the 22 interns this year engaged continually in the community as part of the endless summer of code. Ed, is there any words you would like to say to wrap up our series of presentations?
Just want to, thank you, David, for organizing everything into this more intensive finals week. I think the format was nice to give each of our interns a dedicated time period to showcase their efforts. We're already getting the recordings out on YouTube of the sessions, and I think we'll also try to have each showcase as a standalone recording so our interns can share those as part of their portfolio. We'll be publishing to the blog soon our official wrap-up blog post, which will link to the final reports and the repositories for each of our interns. And then we'll also have a reflections post with some of their final thoughts on the experiences. But want to once again, thank all of our interns, thank all of the mentors and our org admins, and all of the programs who helped to facilitate the contributions and the experiences we're able to take on this summer. But like David said, we're looking forward to this being just the beginning and this being the start of an endless summer of code. Thank you, everybody.
Thank you. Bye.